Yeah, let's go a little bit south down to Aotearoa, New Zealand. Um, geochemical characterization of stone artifacts is well established in Oceania. This technique has provided a key means of identifying spatial and temporal distributions of raw materials and, by extension, social interactions, especially in pre contact East Polynesia, where ceramics are rare and metal was absent. Artifact characterization studies in Oceania have concentrated mainly on commonly occurring volcanic rock types, in particular basalts and obsidians. However, in regions with a continental geology, such as Australia, New Zealand, and Papua New Guinea, sedimentary and metamorphic rocks were also important sources of toolstone. Yeah, stones to make tools. So in this paper, we investigate greywacke, which is a fine-grained sedimentary rock that was frequently used for adze manufacture, but still remains understudied. So New Zealand has a complex geological makeup with a much more diverse range of raw materials compared to the predominantly basaltic Polynesian islands to the north. The first settlers rapidly discovered several sources of fine-grained rock suitable for adzes. In addition to the familiar basalt, two other stone types were commonly utilised for adzes and also other ground-edge tools, which are argillite and greywacke. There was also a variety of other materials, including pounamu, which is nephrite, gabbro, limestone, andesite, and possibly dacite, which were also used but in smaller amounts. So greywacke is a fine sedimentary rock which forms a basement rock in seams across parts of the country. While the majority of deposits do not allow for controlled flaking, which makes them unsuitable for adze manufacture, there are occasional outcrops of fine-grained greywackes that have been identified. So formations can be spatially vast compared to volcanic rock, and the deposits can be old up to 500 million years in Aotearoa, making the material potentially subject to geochemical change via induration, metamorphism, and also weathering. So despite, like I said, despite the variety of stone used for tools in Aotearoa in the past, geochemical analysis of materials other than obsidians have been rare. Consequently, studies have generally been limited to identifying artifacts to rock, usually by handheld specimens and visual characteristics. As a result, archaeological research often assigns a generic, what they've called Motutapu greywacke category, to various types of fine-grained sedimentary rock that visually resembles material from one of our inner Hauraki Gulf islands, Motutapu. This category currently covers all greywacke thought to originate from the Auckland region, and is generally based on visual characteristics such as grain size and also colour. The Pig Bay site on Motutapu Island is adjacent to a source of fine-grained greywacke and contains evidence of extensive stone flaking and also occupation. It was first excavated by Jack Olson in 1958 and recently analysed in detail by Janet Davidson and Foss Leach. Over 270 finished and unfinished adzes were recovered, with all but two thought to be made from local greywacke. Although radiocarbon dates indicate a relatively brief occupation, only around 100 years, the site does have a complex stratigraphy. So archaeologically, Motutapu greywacke has been identified in sites throughout New Zealand's North Island, including the basal layer of Hauhora, which is almost 300 kilometres north of Auckland City. Hauhora is among one of the earliest known sites in New Zealand, dating to around 1250 AD, which suggests that the material was identified as a high-quality resource very soon after initial settlement. However, the main distribution seems to be concentrated in the Greater Tamaki region, Greater Auckland region, within about 100 kilometres from its probable sources. Recently, I analysed 144 finished and unfinished adzes from 8 sites around Auckland, spanning pretty much the pre-European multi-sequence for New Zealand, which was about 1250 AD through to 1800 AD. The dated sites were grouped into 4 main temporal periods, and I found that Greywacke as a raw material dominated throughout and made up 82% of the total assemblage. So from this came some questions. Clearly, Greywacke was an important raw material, but can the Motutapu source account for most Greywacke that we found in Tamaki? Some sites from my research also post-dated the Pigpay site considerably, and there are other flaking floors on neighbouring islands like Rakino and Motuihi, and fine-grained Greywacke deposits also occur on the mainland. Therefore, can other potential sources be identified, and if they can they be distinguished from each other? So therefore, from there, So to investigate these questions, we tried to use a holistic approach. Geologically, the Waipapa terrain Greywacke is the underlying bedrock seam along the eastern side of the Auckland region. And as such, exposures of this would be worth investigating. So first, the geological literature was consulted to locate Greywacke outcrops. On the mainland, 3 locations were chosen: Anchor Bay, which is up in the Tawharanui Peninsula, which is around 80 k's north of Auckland City, and Oriri Point and Kaiawa, which are approximately 80 k's to the south. Similarly, 3 islands in the Hauraki Gulf were selected: Motutapu, Rakino, and Motuihi. All 3 of these have evidence of stone flaking. So after gaining approval from our relevant iwi and also governing authorities, these locations were visited and samples of natural stone were collected. On Rakino Island, for example, there's an extensive stoneworking floor in the intertidal zone at Home Bay, which is kind of hard to see, but there's a lot of flakes, which looks a bit like that close up. So our initial survey on that island identified numerous work cobbles, flakes, and even several preforms. Despite this evidence of adze manufacture, there were very few large natural cobbles, boulders, or outcrops that would have been suitable for the initial stages of adze reduction at this bay. However, suitable materials were located nearby at Māori Garden Bay and Sandy Bay, suggesting that blanks were transported from these relatively exposed beaches to the more sheltered Home Bay for secondary reduction and eventual transportation off the island. A note on Home Bay, we do plan to conduct a more focused investigation there, which will include photogrammetry, total station survey, artefact measurements, and in situ PXRF analysis, so that in this way we will be able to record the site in detail, but with minimal disturbance. We're really fortunate to have Dante Bonica as a team member, who is one of the, if not the foremost traditional practitioners of making adzes and other stone tools. So he came with us and helped us to select suitable samples from natural cobbles and boulders and outcrops from the sources. Back at his workshop, Dante fashioned these stone samples into adzes, both to evaluate the working property of the raw material and for comparative performance testing of finished tools, which that part of it is also ongoing. So finally, those samples that were deemed to be of quality suitable for adze manufacture were geochemically analysed, and although destructive geochemical techniques are generally more accurate and quantify a greater range of elements, they are not always practical for investigating archaeological questions. And for this study, we required data from multiple samples per source to gauge inter-source variability, which would not have been financially viable using destructive methods. Additionally, in Aotearoa, New Zealand, and also elsewhere, Indigenous peoples have gained greater control over their curation of their heritage and rightly question whether destructive analysis of artefacts are always necessary or warranted. So given these potential limitations, non-destructive geochemical analysis were carried out with a Brooker Tracer 5i portable X-ray fluorescence instrument. Our investigation is ongoing, but to date, 120 source samples from the 6 locations have been characterized. Our results agree with published geological data, and while some patterning is apparent from examining individual elements, for example, the trace elements strontium and rubidium show some partitioning of mainland versus island sources, there was still quite considerable overlap among individual sources. So we went multivariate. So multivariate approaches such as discriminant function analysis, random forests, and support vector machines, which incorporate a range of elements, have been more promising. The mainland and island greywackies can be unambiguously separated. Within those regions, individual sources can be discriminated with a high degree of confidence. That's those. So our initial results, and although more potential greywacky sources still need to be investigated and additional reference samples need to be added to the database, our initial results do look promising. A sample of 42 adzes from 5 sites in Auckland were non-destructively analysed as well with PXRF and compared to the reference data. The resulting source assignments indicate that stone from all 3 islands in the Hauraki Gulf were used for adzes. So in summary, although considerable work has been conducted on various aspects of stone tool manufacture, usage and distribution in New Zealand, there remain several areas that require additional study. Geochemical analysis are essential to understanding the spatial and temporal movements of stone artifacts among social groups, but to date, obsidian is the only lithic material in Aotearoa that has been systematically studied. For other lithic materials, identification is almost always done by visual means alone and generally limited to regional stone types, such as Motutapu greywacke or Nelson Marlborough argillite as well. So with this level of characterization, it does provide useful information at a regional scale, but it's too coarse to address more subtle questions. For example, with different groups targeting the same locations within regions, was there change over time as resources became depleted? So our pilot study does indicate that geochemical variation among different greywacke exposures exists in the Auckland Tamaki region, and that PXRF provides a viable means of non-destructive mass analysis of both reference samples and artifacts. However, before geochemical analysis can be conducted, sources need to be identified and comprehensive reference sample sets need to be collected. So there's a lot more research to go into that space. Cool. I'd like to thank these people, our field team, our local iwi, Ngāi Tamaki, and the Royal Society of New Zealand, who gave me a tiny bit of money.